I'm Christian Eggeling. I'm a Professor of Super-Resolution Microscopy now in Jena in Germany, the city of microscopy. I'm at the university as well as the Leibniz Institute of Photonic Technologies there. Formerly I was in Oxford, still affiliated there with the Weatherall Institute of Molecular Medicine at the University of Oxford. My curiosity in science actually began, well, in school I was good at science. I was good at math, I was good at physics, chemistry. That's why I chose, let's carry that on. And doing my studies, I never thought I would become a scientist. But somehow it evolved. I had a very curious master supervisor and PhD supervisor, and that somehow dragged me into science. And we did back then, he said, we are doing something completely new, because he wanted me to do something else. And we did, he said, we're going to study single molecules with a microscope. And I said, this is not possible. But as you can see stars in the sky, you can see single molecules under a microscope. Fantastic time. And that's how it started to get me into the academic career and the science. I'm interested in my current field to use microscopy to learn new things in all kinds of areas of cell biology. We are doing a lot in infection and so on. And I want to drive applications to learn what do we have to do better with our microscopes. How do we still have to improve it? Because back then I did my work for a long time with Stefan Hell, Nobel Prize winner, and we just improved microscopes. Yeah. We did something, and we did so many improvements which at the end were of no use for the people. Still cool stuff, and now with Oxford and now in Jena also, we have to apply it to show that it works and to learn what we still have to improve. My favorite thing about being a scientist that I can explore things, that you have the freedom to dig into new stuff. I was working after my PhD in a company, Evotec. Fantastic time, but often we had these project-driven things, and on the side I saw some problems popping up, but this was not of no interest because we had a clear goal to achieve there. And in science you often can go sideways and explore new things, and often these sideways, these are the important things that lead to important discoveries as well. My curiosity is mainly fueled by working together with young scientists, students, PhD students, postdocs, that are eager to learn new things, to investigate new things, and to motivate these people. This is the most fun I have in being a scientist, and let them explore also. Often I just let them explore new things, although it was not my primary goal with them, but it often gets us somewhere. So what unresolved process or scientific question I want to master? Of course, on one hand, I'm a microscopist. I want to know how much really does super-resolution microscopy bring us at the end, and can we use it as a tool in the field, that everybody can use. But on the other hand, I'm a biophysicist guy, so there's a lot. I'm doing a lot on membrane organization, and there are certain things, for example, heterogeneities in the membrane organization, especially of lipids, which are the major part of the membrane, and how these lipids shape function in the cell, shape proteins, how they come together, and whether they are an active part or whether they are a passive part. If I would have magic powers, I would improve the funding situation. So we are writing a lot of grants, we are fighting with administration. If I had superpowers, I would simplify that all and challenge more money into the system. I'm a curious person, Otherwise I wouldn't come back to academia. As I said before, I was in industry. Why did I come back to academia? Because I was curious. curious about new things, other things to explore, and curious to work together with people that are curious on themselves. Where does my curiosity take me next? It's a difficult question because I often work on short-sighted. Yeah, so we are always looking from one result to the next and where that takes us. So I would say my curiosity will take us wherever our experimental results take us.